recycled concrete aggregate and addition of cane baggage ash on the corrosion rate of reinforcing steel. Introduction. Building elements made with cement base contribute to the deterioration of our environment. The pathologies presented by reinforced concrete considerably reduce the mechanical strength of the structure and make it more expensive to maintain such a corrosion. Study materials. Recycled concrete aggregate from the crushed blocks. A percentage of 67.67% of material classified as gravel was obtained, and 32.33% of sand. Particle sizes less than 4.76 millimeters. The nature of the demolition product concrete influences the results of characterization, mechanical tests, and durability. Cane baggage consists of approximately 50% cellulose, 20% hemicellulose, and 20% lignin. Experimental procedure. The characterization of the stone aggregates was carried out in accordance with current Mexican regulations. The tests were carried out to note the volumetric masses, densities, absorptions, and particle size distribution. Cylinders of 10 times 20 centimeters were made to subject them to compression and electrical resistivity tests. Prismatic samples of 5 times 10 times 20 centimeters were prepared for the experimentation of electrochemical tests. The steel under study is grade 42 placed on rows of 3/8 inches in diameter. Graphite was used as a reference electrode. The specimens were subjected to wet-dry cycles in water with a concentration of sodium chloride at 3.5% by mass. Corrosion potential and polarization resistance were measured. A potentiostat brand gamma ray was used, evaluating with the technique of resistance to linear polarization. Results. Conclusions. Based with replacement of cement by SCBA require more time to complete the setting times. The density of the RCA aggregate is lower than the natural aggregate, with porosity that allows greater water absorption. The values of corrosion potential and corrosion velocities were lower for the control mixture and higher for the mixture with RCA and SCBA.